Welcome to another video episode on my Arduino Mega2560 Series 2. Well, the board is not Series 2, the video is from Series 2. And that deals with the C language, electronics, and since last episode, one piece of fischertechnik. The problem is, oh, by the way, not C, it is Octave. Octave is a mathematical programming language, very much suitable to gathering information, data, putting them in a matrix or a vector, and putting them in graphs. However, to get that, you have to set, in this case, pulse modulated signal to the circuit, from here to there, of course. Then press a switch, which used to be this one, is now replaced by this one. And then when pressed, two LEDs start lighting up. This one is one that only that it gets power from there. This one gets power also from here with an inductor and a diode. And right now the question is, when I press the switch during operation, then two things happen. First, the pulse width is getting bigger towards the towards the situation that the whole signal is only one, is full width. After that, the pulse width is being decreased until 0. Last time I found out that 0 isn't 0, which is a confusing fact. 0 is actually a very, in this case, a very low number that gets near 0. The right mathematical term escapes me right now, but it's approaching 0. And therefore the vector that I want to fill entirely with a 1 is not filled with a 1. So that is all for last time. So now let's run it. And I have to press F5 to run it. And then things have to happen. This lights up, this one lights up. Then, when everything is right, when the whole cycle is done, the red LED will flash. And if both elements are one, the green one should flash, but that likely never happens. So now I have one cycle done, and I will press C, Ctrl C actually, and then I will see whatever happens, and I already see that things don't go the way they intend to happen. So also happened last time, but let's check out the gathered data, because that just raises a lot of questions. So here we are. This is of course the situation that you just saw. Oscilloscope is just now the incoming pulse modulation. This is probing just here right after, but I should put this for now here. So this line is right here before the transistor. This line, no, I'm wrong. This line is right here on the other side of the switch. Then this line is after the transistor, and this line, this is from the probe right on this side of the circuit. Anyway, I press the switch, and what happens? Initialization 0. Then increasing pulse width, like I'm doing here, increasing the pulse width. Then after what? Well, after increasing, and that is I. I is 1. That's good. It should be 1, not smaller than 1, just 1. Then between, answer is 0. What answer is 0? Well, actually, if this is correct, then the answer should be 0. Point is it? Here I read the very first time from the switch, and it says it's not okay. So while everything is correct, it is 1, it should be 1, it isn't read 1. And that is right here. So while this happens, this should happen. And the big question is, why? Yes, it is pulse width modulation. Yes, it has up and down. Would it be that, like here, that's not entirely correct? Is it 5 volts or lower? No, it's the plus is 5 volts. It's just that this isn't entirely correct. I should check out why this is in wrong location. Maybe I can change the setting in the oscilloscope that it is up again. I should find it out. Recalibration or something. Anyway, this is not good. And what I mentioned, this should be 0, but well, something to the power minus 16, or not times 10 to the power minus 16 is a very, very, very small number, but not 0. Yeah, it should be 0.000, etc., but it's clearly not. So what should it do? What should I do to improve this? Clearly, here I cannot get the right signal. What I could do, no, I can't. I thought maybe if I keep this above 0.1, then I would get 0, but that's not the idea. But what really worries me is this part. How to solve it. Is it timing or whatever? Right, so let's examine the algorithm again. Initialization of the 2 row 1 column vector or matrix. Increase the pulse width. Then show that or show the value after the for loop. Then this is actually meant for a check after the first time. So the first time this won't happen. This will show 0. But no, it won't show 0 the first time, because the first time this is always 0. So it won't even comply to the condition. Then read digital 4, which is this one. Press the switch, this signal goes in here, and since the reading happens when it's 1, it should be 1. So if this is 1, it should be okay. And it should be 1 because I have here D2. And it won't read it until this is fully completed. After completion, this is being done. Read. Then this should be 1. And what I could also do, but that's not reading, or in a matter it is. No, I want replacing this by I, because here I is, but it is the signal that I want to read. So I am reading the signal that should be 1, the value 1. Decrease the pulse width, and that's it. So let's go again. First quit and press everything runs except the algorithm. Go. Increasing of the pulse width. Decreasing the pulse width. Increment again, and the LED gets brighter. And okay, let's stop it. Yeah, okay. So let's examine again. Yeah. Now it's okay. That's good. Well, here we have something that is supposedly 0. Then D2 element 2 is once again not okay. And let's go forward. And S2 is 1. If S1 is 1, yeah, okay. So S2 is becoming 1 because the first element is 1. And then we go forward again, but we have quit. So now it has been working. For about everything, and yes, the first time S2 is nothing, and the second time S2 is 1. That works. Still, the question is, of course, why did I get a 1 for the second element then at all, if it is clearly shown to be 0? That confuses me, because D1 or D4 after the while is nothing, is 0. What to do about it? Alright, another thing is, how do I know that everything stays the same? I interrupt it after 1 cycle. So, now it gets a bit tricky, because I need to hold the switch and then run the program and then have it run for some time. So let's go here. I didn't really change stuff. Alright, go. And let's do it for 3 times. It's really weird. As if the voltage over the line, over the yellow line, gets lower and lower, and where's my cursor? This is the yellow line. So let's just complete 3 times. And okay, that will be it. So let's forward, or let's just see how far this goes. Okay, this is an okay anyway, that's good. 138 78 is this, which is the same as there. Okay, what happens then? 2 is not okay again. Forward. Now it is 1. That's understandable. And here it remains 1. Is that logical? Is that explainable? No. But it is, that's good. Same value again. This is 0 again. Forward. 1 0 1 0. Same value. And once again, same value. And that's it. 3 times. The only question is how low is this value? Well, if you count 60 times that direction, because it's a minus with the exponent of minus 16, yeah, it approaches 0. You can safely assume that. So, where to go next? How to go next? This one hasn't ever been lighted, but that is because D22 is depending on S1 being 1. And that's still a question, because how can S1 be 1 when it is 2 elements? And 1 is usually unity. And unity is 1 0 0 1 is actually 4 elements. And I have 2. Can that be unity as well? I do think so. But I'm not quite sure. So, where to go from here? Well, I'd love to have something that has the second element as well, including some backlash from here. Would that be something? Because this is actually giving a backlash voltage through the transistor. Oops. This is not good. Why is this not cooperating? Now it is. So actually this gives, because it is connected to the 5 volts instead of to the ground. You see it? Yes. So the resistor and the diode are connected to the 5 volts, to the mains. So this gives a 5 volt backlash. When I press, the LED is burning. Not very bright, but it is. And that should give a nice voltage back. Also through the 4. Is that really happening? According to schematics it is. The point is just that I do not have enough entrances in the oscilloscope to actually measure that. This isn't quite as stable as should. So what if I just press? Then after the oscilloscope it gets the same idea, yeah. So you're reading from here. What if my whole idea is wrong? That I should actually read from yet another point. I think that is a nice one to measure that one as well. So I have to add another wire. So from here to there, and see how the voltage applies to that. Would it matter? I don't know, just find out. Right, now with the following situation, new wire running from here to port 6, which I also have to put here. So this is this part of the circuit with the inductor. Then from here to port 6, so that's not nice. So how to do this nicely? That is one, and this this becomes 6. And this goes all wrong. This goes all wrong. Right, then we do it this way. Or just like that. That's better there, probably. And then from here, no, that's wrong direction. From here to the here, yeah. Then I have to put it into the code as well, and will be just a simple thing. As 3 is, and then copy, paste, make that 6, and print as 3. So this should make more or less clear what value this is. And another thing is, I'm not even sure I should read it digitally or analog. Analog gives a very different value, of course, since this doesn't burn as brightly as this one. So that's a question. How to do that one? I can easily change this to analog, and then of course I will have to relay the wire to one of these pins, because these are the analog pins. But let's run it for now and see whatever it gives. And I don't even have to hold the switch for this. But let's just do that. Doesn't matter. Doesn't really matter. And Right. Bright red flash, so I will have gotten the whole thing. Okay, exit. S3 is 1. And where did I start? I started here. So S3 is just a full 1. And how it will behave analog, that's another question. That I will have to test next time, because time for now is up. But it will be interesting what value this will be in analog range and this one. Because although when I press the switch all signals show pulse modulated behavior, this is not pulse modulated. This one is pure analog, because this is an analog component. So that makes me very curious how that will be. So that's it for now. With one wire added, and it should stay in its socket. That will be very helpful. Oh wait, this is wire 4. Should stay where it is. And that's not helping. Alright, anyway, thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Also, leave a comment or suggestion. If you can also follow me via Instagram and Twitter. Please support my channel by making a donation via either PayPal or Wired. And you can also become a patron and have your name mentioned on my website, and depending on the pledge you make also with my videos. This is obviously going to be continued. So for now, once again, thanks for watching and have a nice day, and bye bye.